Hello everyone, welcome to this video. Let's solve the problem of the day. Today we have power of 2. Okay, let's read the question. The question statement says, given a non-negative integer n, the task is to check if n is a power of 2. And more formally, we can say we have to check if n can be expressed as 2 to the power x for some integer x. Okay, so the problem statement is pretty simple. It is just asking you to check this n, which is given as a parameter. You have to check that if this n can be expressed in the power of in the type of 2 to the power x. Okay, so if it is a power of 2, you have to return true, else you have to return false, right? So it is pretty simple. You can see the examples as well. When you are given n as 8, yes, we know that 8 lies in the power of 2, so we can say yes, that we can basically return true, and it will be yes. Example 2 says when n is equal to 98, and 98 cannot be expressed in the power of 2 to the power x, in the type of 2 to the power x. Okay, it is not in the power of 2. So the answer is going to be no. Okay, let's see how we are figuring these things out. Okay, here are the same examples, but now we are going to check them out with some different approach. Okay, so if I have to write all the power of 2's, so I can begin with 2 to the power 0, then we have 2 to the power 1, and further on like this, correct? So if I assign the values, it will be 1, it will be 2, this will be 4, and this will be 8, right? So once we check like this, we can figure out, yes, that 2 to the power 3 is actually equal to 8. And if it's so, we can return true, correct? This is the condition where we can return true. And now if we have to check for 98, right? So the procedure is going to be a little lengthier. We have to begin like this, and let's go till 2 to the power. Okay, just let's write all of the powers. Further on, we begin with 1, this is 2, this will be a 4, then 8, 16, 32, then here goes your 64 and 128. So here you can see one thing. You have to notice that at this point, till this point, we still had a chance that we can have 98 as a power of 2. But when we jump to here, when we go to 2 to the power 7, there is no chance that we can get 98 as a power of 2 because we have exceeded the value, right? So at this point, this could be the breaking point and we can return false. Okay, we can think of it in this way and we can generate the values as well. But this is going to be very basic, correct? We can go a little smarter. What if we try to figure out the bits? Okay, bits do hold some special abilities and properties. Let's try to see our 8 as in the form of bits. So if I say, correct? So if I have to represent 8, what it will be? It'll be like this, correct? This is the representation of 8. And if I have to represent all these power of 2's in the form of bits, how would it look like? It'll be 1 for 2, it'll be 1 1 0. For 4 it'll be 0 0 1. For 8 it'll be 0 0 0 1. Similarly going down, it is going to be getting increasing like that, correct? So are you able to notice a pattern here? Well, this is the pattern that is going to give us our answer. Okay, so every number that lies as a power of 2 actually has only one set bit in their binary representation. You can see only one set bit is there and all the other bits are 0. That means all the other bits are unset. Fine. So if there could be a way that when we are given a number, let's say 98, we can convert it to the binary representation of it, okay, with some ones and zeros, we can convert it to the binary representation of it, and then we can check in the binary representation if it has only one set bit. Okay, so whatsoever number we are given, we have to just figure out that how many number of ones it has. If it has only one single set bit, that means we have to return true. If it has more than one set bit, that means it is not a power of 2, correct? And in that case, we can return false. Pretty simple. But how we are going to do that? So for that, let me first tell you how you can actually traverse a binary number. Okay, assuming let's take this sample binary number. One thing you must notice is we can access this last bit, and by access I mean like we can check if it is set or unset. How? Like this. If we do n and 1, what is the property of and? Assume you are given this number 10110 and you and it with 1. So once you perform and operation with 1, it will look something like this. Correct? So once this is happening, what it will be? It will be completely zero. Correct? It will be completely zero. And this is zero because when we are putting and here, that means 0 and 1, it is resulting in 0. In some other case, if we had 0 and like if this was a set bit and we would have done the same thing here, then when we perform and, we would have gotten 1 and 1, which is resulting in 1. Correct? So when we and some number, okay, with this n, or you can say the given number, there are two possibilities. Either the number will turn into 0 or the number will turn into 1. If it is turning into 0, this will tell us that the last bit is actually unset, and if the number is turning into 1, this will tell us that the number is actually the last bit is actually set bit. Okay, so we know how to access the last bit, so we are clear with it. But how we can get to see each and every bit, how we can see that if all the bits are set or unset, or each and every bit are set or unset. So for that, what we actually need to do is we will keep on checking this last place, and just after checking the last place, what we'll do, we'll perform a right shift operation. So when we perform a right shift operation, what will happen is all the bits will be shifted one step towards right. So this 0 was there, this will be gone, and this one will be here. Okay, it will go like this, and the number will be shifted. So at the last position, now we would be having this second number. Okay, if we count it like this, so at the last position, now we'll be having the second number. And further on, once we perform n and 1 here, we'll be able to figure out that if this is 1 or 0. And once we are done with this step, we will again do the right shift operation. Then we'll be left with 101, right? This one will fall off, and then we can check this as a last bit. And this is done using this format. Okay, what we are basically doing is we are performing the right shift operation until the number exists. Once the number ends, that means it will turn into all zeros. That is this condition. We have to keep on performing these operations until our n is greater than 0. Okay, this is the condition, that is checking if the last set bit is 1 or not. If it is, then what we can do is we can increase our you can say increase, or you can say we'll right shift our number. All right, and now we are clear with how we can check that if all the bits are set or unset, or what I mean by all is we can individually check if each and every bit is set or unset. Once we are clear with it, how we can approach our question with it? Our question is to check that if there is a count and the count is holding number of set bits. If that count is 1, we have to return true. If that count is any other thing, we have to return false. All right, so let's see the approach for the question. So very simply, we have to check if the number is 0, we can return false. We do not even need to check anything because it cannot be expressed, right? Then what we have to do is we have to initialize the counter with 0 because we have to keep a count. Then we will traverse the bits just like the way I showed you. And then along with the traversal, we'll also keep on counting the number of set bits. That is the condition. If we are going inside this if, that means we are encountering a set bit. And this is when we'll also increase our counter. Fine. So once we are done with the traversal, our count will be holding the number of set bits. Then we have to check that if number of ones means number of set bit is 1, we have to return true, otherwise we have to return false. Pretty simple. So if I have to check that in the like in the form of code, here is the code. I've done it in Python. Just very simply, I have checked if it is 0, I'm returning false. Other than that, the same things that I've said. I'm keeping the count to be 0. I'm checking the same while, just like we saw that. And I'm performing the traversal. Along with that, I'm keeping account of it, and I'm returning the bool value. If the count is equal to 1, that means it will be returning true. And if the count is any other thing, it will be returning false, right? Let's also discuss the complexity of it. Well, we are actually traversing the number, correct? We are traversing the number. And that number can be expressed in log n. What I mean is, if you're given a number and you find out log of it, that will give you in how many bits that number can be represented if we are taking 2 as the base. So this is the complexity of it, because we are not going to traverse anywhere more than that. Okay, let's run this code and check if it is working properly. All right, here's the same code. Let's compile and run it. Okay, so it is compiling correctly. Let's try to submit that and see if it is passing all the test cases. Okay, so it is passing all the test cases. So I hope you understood the problem well. Keep coding.